We have this problem here that says BD and CE are altitudes of triangle ABC such that BD is equal to CE. So BD and CE are altitudes in triangle ABC. So BD is making 90 degree with AC and CE is making 90 degree with AB, and both these two altitudes are of same length. Now, state the three pairs of equal parts in triangle CBD and triangle BCE. Now let me quickly, highlight this triangle CBD so that the triangle CB, we can differentiate between triangle CBD and triangle BCE. Okay. So what are the three pairs of equal parts in triangle CBD and triangle BCE? First of all, let's write here triangle CBD. This is triangle CBD. Let me mention it here, triangle BC. Okay. So in this one, angle D of triangle CBD and angle E of triangle BCE, these are equal. Why? These both angles are at right angle, that is 90 degree. Then we have this side BC in triangle CBD and the side BC for triangle BCE, right? This is the common side to both the triangles. Okay, so this is the first pair of equal parts. This is the second pair of equal parts in these two triangles. The third pair will be what? That is given here. BD is equal to CE. Therefore, BD of triangle CBD is equal to CE of triangle BCE. Now, you can see here, we have actually found the three pairs of equal parts in triangle CBD and triangle BCE. So we have solved for this one. Now, you can see here, two right angles of two different triangles are equal, that is R. BC is actually what? Is the hypotenuse for both the triangles, right? And why it's hypotenuse? Because in triangle CBD, angle D is at right angle and the side opposite to angle D is what? BC, that's what here. In triangle BCE, angle E is at right angle and to the opposite of angle E is BC, and that's what we have written here. So two hypotenuse BC and BC, then it's H, and then BD is equal to CE. It means that the two another sides, right, apart other than the hypotenuse are also equal, BD and CE. So RHS. RHS is what? RHS Congruence Criterion. RHS Congruence Criterion is being satisfied. Two right angles are equal. The hypotenuse of this triangle is equal to the hypotenuse of this triangle. And another side other than the hypotenuse of this triangle CBD is equal to another side apart from the hypotenuse of triangle BCE. These two sides are equal. RHS Congruence Criterion is being satisfied. Yes, these two triangles are congruent. But whenever you are asked such questions, like you can see here, is triangle CBD congruent to triangle BCE? Always check for the correspondence. You know why? Because I can write this triangle as triangle CBE. I can write this triangle as BCD. And then I'll say that yes, these two triangles are congruent. But when you have to represent it, you always have to fulfill the condition of correspondence. You have to tell the correspondence. By correspondence, we mean, let me explain you like this. What I'm going to do is, I'm quickly going to separate these two triangles and I'm going to draw two separate figures for these two triangles. So for the first one is for triangle BCE. It's a rough diagram. The thing is, when it comes to correspondence, most of the students make mistake when it comes to identify the correspondence. But I'll explain you very properly. so that you'll never make mistake again. So this is BCE, this is at right angle, and let me draw for CBD. Okay, it's a rough diagram, not looking very accurate, right? Okay, B, C, and D. Now, if we look at these two triangles, and if we are trying to fulfill the correspondence, that we have to tell the correspondence of these two congruent triangles. Imagine that if you take this triangle and if you try to superpose this triangle on this triangle BCE, then since these two triangles are congruent, therefore this triangle will completely and properly fall over BCE. That is, one of the vertices of this triangle will fall on B, one of the vertices of this triangle will fall on E, and one of the vertices of this triangle will fall on C. Okay, now don't think that this is B vertex of this triangle and this is B vertex of this triangle, therefore surely B will fall on B. No, it's not always the case. Sometimes it depends upon the correspondence condition, but it's not always true that if the vertices name are same, then those two vertices will be in correspondence. That's false, and that's where most of the students make mistake. So now if you are unable to think that which vertex will fall on which vertex if we try to superpose this triangle on this one, I'm going to tell you a very quick way to identify. Now you know that these two triangles are congruent, and the information that has been given to us is like this BC is the common side, right? This BD is equal to CE, that's given to us. Now since we have established that these two triangles are congruent, it means that the third side will also be equal, right? Since the two sides are equal, the triangles are congruent, therefore the third side will also be equal. Now take any two sides which are equal to each other. Like in this case, I'm going to write of triangle BC, of triangle CBD. First I'm going to write for triangle CBD, right? So this BC is equal to, now for this triangle BCE is equal to BC. Take any two pairs of equal sides, and let us take again this pair which was given to us. CE is equal to what? BD. So this BD is equal to CE. Now look at these two pairs of equal parts and first look for this triangle CBD, which is a common vertex. B is here and B is here. Okay, now look in this RHS side, that is for triangle BCE. Okay, which is the common vertex in both these two pairs of equal parts? C is common. Therefore, establish that this B and C are the corresponding vertices. That is, when you'll try to superpose this triangle BCD on triangle BCE, then the C vertex will fall over on B and not this vertex B. That's what I was trying to explain you earlier. That do not go with the name of the vertices. The correspondence is completely different than what you think. Don't go with the name of vertices. Okay. So the quickest way is just write two pairs of equal sides, but always write in a way that the sides of the same triangle fall on on the same side. Like in this case, I have taken this triangle CBD as the LHS. So on the left hand side is triangle CBD and on the right hand side is this triangle BCE, right? Now this B and C are corresponding vertices. That is, the vertex, this vertex B of triangle CBD will cover vertex C of triangle BCE, and the vertex C of triangle CBD will cover the vertex B of triangle BCE. So this is here. Sorry. Again, this B vertex is of which triangle? Triangle CBD. This one. This one will cover vertex C of triangle BCE. This C vertex of triangle CBD will cover which vertex? Vertex B of triangle BCE. And from here you can see D and E are the corresponding vertices. It means that the D vertex of triangle CBD will fall over or cover the E vertex of triangle BCE. Therefore, this is the correspondence. What's the correspondence? B vertex of triangle CBD and C vertex of triangle BCE. Then from here C vertex of triangle CBD is in correspondence to B vertex of, from here, B vertex of triangle BCE, and then D vertex of triangle BCD CBD is in correspondence to E vertex of triangle BCE. Therefore, in short, you can sum up these as BCD and CBE. This is the correspondence when these two triangles are congruent. Now, look here. This is what? Let me write it here. This is triangle CBD is congruent to triangle BCE. Okay, so the C vertex of CBD is in correspondence to B, right? This C is in correspondence to B. That's correct. Then this B is in correspondence to C. So this B is in correspondence to C. Then this D is in correspondence to E. This D is in correspondence to E. That's why the correspondence is important. You know why? Because I can even say that this triangle as the congruency, I can represent it as triangle BCD is congruent to triangle CBE. Why? Because I am fulfilling the correspondence in these two congruent triangles. That is why this order, that is a correspondence, becomes important. Now you can see that this is triangle CBD is congruent to triangle BCE. We have established it. Yes, it is. But I can say that even triangle BCD, I have just interchanged the position of C and B. And then here I have interchanged. Why? Because I have to fulfill the correspondence. B vertex of this one will fall on C vertex of this triangle. That's what the correspondence is. Now, sorry, there's another part. Is angle DCB equal to angle EBC? Yes, of course. Why? Because this B and this C will fall over on each other. Like these are two corresponding vertices that we have established here. Of course, if these two are corresponding vertices in two congruent triangles, it means that yes, these two angles will be equal. Angle B and this will be equal to angle C, right? Because they are corresponding vertices. In this question, it is ABC is an isosceles triangle with AB is equal to AC. AB is equal to AC and ABC is an isosceles triangle. And AD is one of its altitudes. AD is one of its altitudes. It means that AD will make 90 degree with BC. Now, the first part is state the three pairs of equal parts in triangle ADB, and triangle ADC. You have to state the three pairs of equal parts. Okay, let's begin. We have two triangles that is this triangle and this triangle, right? So in triangle ADB, first write triangle ADB and then let's write triangle ADC. We have to write the three pairs of equal parts. What's the first pair that will be equal? You can see here this angle BDA, right? This angle BDA of triangle ADB, this BDA, right? In short, we can write angle D of angle ADB is equal to angle CDA, angle CDA. In short, we can write angle D of angle triangle ADC, right? Why these two are equal? Because they both make right angles. They both are at right angle. Therefore, these are equal to 90 degree. Now next, this is the first pair of equal parts. The second pair of equal parts, if you can see here, this AB is equal to AC. So AB of triangle ADB is equal to AC of triangle ADC. And why? Because it has been given here. Okay, this is the second pair of equal parts. So till now we have the two pairs of equal parts. The third pair will be what? This side AD is actually common in these two triangles. So AD is equal to AD is what? Why? Because they are common sides. Okay, now the two right angles are equal. The two hypotenuse of triangle ADB is equal to hypotenuse of triangle ADC, and the other side, another side of this triangle, that is AD, is equal to the another side apart from this hypotenuse AD of this triangle are also equal. So two sides are also equal. RHS criterion is being satisfied, congruence criterion is being satisfied. Therefore, according to RHS congruence criterion, these two triangles will be congruent. Now again, whenever we talk about congruency, we always think of correspondence. We have to fulfill the correspondence. Okay, this is not very tough as, difficult as this one was. Why? Just imagine that if you take this part ADC and around this line AD, you simply fold it on this side. Take this triangle and around this line just fold it. You can clearly see that this AC will fall along AB, right? Just imagine like you're folding around this line. So this vertex C will fall on B. This AC will fall along this AB, and this AD is the common. So it will completely superpose this triangle ADB. So what is the correspondence? B vertex of this triangle ADB is in correspondence to this C of ADC, right? A of this one will be in correspondence to A vertex of this one, and D is same thing, like this D will completely fall on this D. So D vertex of triangle ADB and D vertex of triangle ADC are in correspondence. If we take them together, this will be BAD and CAD. This is the correspondence under which the two triangles will be equal. Now take this one. This says triangle ADB is congruent to triangle ADC. Is it true or false? So ADB in this one is congruent to ADC. So A and A are in correspondence. Yes, true. Then it is D. So D and D are in correspondence. Yes, sorry. It's true. Then B and C are in correspondence. Yes, true. Yes, these two, this is correct, right? Because it's satisfying or fulfilling the correspondence. Now, is angle B is equal to angle C? Angle B means what? Angle ABD. And angle C means what? Angle ACD. Yes, it is true. Why? Because these two are corresponding vertices. Therefore, yes, since these two are corresponding vertices, it means that angle B will be equal to angle C. Is BD is equal to CD? Yes, of course. We have established that these two triangles are congruent. This was already the common side to both the triangles. This side is equal to this side. Therefore, of course, the third remaining side will also be equal to each other. And even you can think of it as, if you try to fold it, then this CD will completely fall along this BD. Yes, BD is equal to CD because the two triangles are in correspondence.